Xingling and Jingsam. If you have any, okay, anyway, let's start today's lesson is about pressure for Form 4 SPM, right? I think Jingsam attended the class one time. Let me just refresh you a bit on how this class is going to be done. We are actually teaching you Brain Drawer. Brain Drawer is a 10 steps learning method. So we are going to go through step 1, step 2, step 3, step 4 until step number 10 in these 2 hours. And let's see what's the starting time. Starting time is 6:12 a.m. now in Saudi. So the goal is to learn this Brain Drawer, right? The goal is to learn this Brain Drawer, because when you understand this study method, you can actually learn any subject. You can learn physics for this case. You can learn chemistry. You can learn biology. You can learn history or geography, right? And for these 2 hours, our objective, our goal is to get 10 out of 10. It's in step 10 of the MCQ. Because end of the session, we're going to have this very quick assessment to see whether if you understand the chapter well, right? Now, let's do step 1. This is step 1. Step 1 is we have to remember that there are how many drawers and what is the name of the drawers. So we have 6 drawers, right? Usually we have 4 or 5 drawers, but this particular chapter we have 6 drawers. So this 6 drawer is pressure in liquid, number 1, atmospheric pressure, gas pressure, Pascal principle, Archimedes principle, Bernoulli principle, right? So to make it easier for you to remember this, I have this story for sure. But before that, there are 6 drawers. 3 of them are related to pressure. 3 of them is related to principle. So 3个 pressure, 3个 principle, right? Now, how do you remember the name of the drawer? I created this story. So now, let's turn your mind into a story mode, right? So how to remember this story? You need to imagine. Imagine this is happening in the story. Okay. Liquid evaporate. Okay. I think everyone knows what is evaporate. To gas. Papa achi, 打喷嚏, achi, sneeze at baby. Right. So what does it mean? Liquid is to represent the liquid pressure. Right. Remember that the first 3 are related to pressure. So there are 3 types of pressure: liquid pressure, atmospheric pressure, and gas pressure. So evaporate. Okay, I intentionally changed the spelling from evaporate to evaporate. Sounds a bit similar, to represent atmospheric. So AT. Okay, to gas. Gas obviously is gas, right? So liquid evaporate to gas. Papa achi at baby. Papa is representing Pascal. Papa sounds like, Pascal, PA. Archie, obviously, is the Archimedes. Baby is the Bernoulli, right? So you can imagine if your house has a baby, or your friend has a baby, or you have you meet a baby recently, you can imagine the baby is in front of your papa right now, and your papa accidentally Archie in front of the baby, and the baby is having full of your papa Archie, right? To make the story more emotional or more silly or more funny, then that will help you to stick this story inside your mind. All right. Liquid evaporate to gas, and papa Archie at the baby, right? Now, if you have pen and paper, please take it out. I think this is important. Write this down. 1, 2, 3, 4, 5, 6, 8, 9. Only 9 words. Write this down, because this is going to be your reference. right? Write this down. Whether you write it down in your in the notes, or whether you write it down in a paper, it's fine. As long as you are able to see this again every time when I ask you, what is the main story? Right, this is the main story. Right, this is the main story. Okay, I'll give you 10 seconds or 10 seconds to write it down while I'm pulling out the clock app. Right. Okay, so I assume you have already write it down, and by writing it down, you already have some. It helps you to remember. Liquid evaporate to gas. Papa achi at this baby, this cute baby, right? And this cute baby face is all covered by your papa achi, right? Very disgusting, right? So let's go to step number 2. Step number 2 is I will need you to read this because there are 6 drawers. This is quite a lot. So read from from drawer 1 until drawer 3 here. Let's I'll give you maybe 1 minute to read. Okay. Okay. Before that, by the way, don't worry if you do not understand what you have read. The objective is not the objective for this step number 2 is not for you to remember to understand everything. It's for you to have a warm up, to know that in drawer 1, this is drawer 1, there is something related to the liquid pressure, depth of the liquid, density. There's a formula there, right? And then here there are some characteristics. Characteristic. Then there is some another equations. Then these applications, right? So there are 3 things. Point 1, 2, 3, right? Then drawer number 2 is also 3 points. It's about definition. Then there is this measurement, and this measurement they have 2 type of barometer, 14 and aneroid, and there is units. Okay, if you don't remember this, it's fine. Don't worry. Just know that there are some units that you need to learn later, right? Then effect of the atmospheric pressure. What is the effect? Okay. Then drawer number 3, you know that there's something related to water manometer and mercury manometer, right? And there's these equations and this device that help you to measure the gas pressure, right? So I'll give you 1 minute to read this. Then we'll continue on drawer 4. Let's start now. Again, don't worry that if you do not understand, this is normal. Fifteen seconds. All right. So these 3 drawers, at least I think you remember there are the name of the drawers. Right. Remember the main story that is right in front of you. Liquid evaporate to gas. So first drawer is liquid. Second drawer is atmospheric, evaporate, right? Atmospheric. Third drawer is evaporate to gas, right? That is the story. So at least you know there are 3 drawers and the name of the 3 drawers, right? By reading this, like I say just now, like I explained just now, for liquid, you have something related to liquid on this. There's an equation, there's a formula that's related to the liquid to calculate the liquid pressure. There is depth, there is density, there is gravitational. characteristic that you need to learn later. Now it's just like a warming up session for you to know that there are three characteristics. Then there is this atmospheric, there is this actual pressure on how you calculate this. Then there is some application. There are four as example. The dam construction, the IV bag. If you go to the hospital and when you're sick, then there's IV bag on you. The injection. That's how the principal application is being done with using the liquid pressure. Then you have the water tank, right? And your YouTube density comparison. Okay, same goes to atmospheric, which I explained just now. There are 3 points: definition, measurement, and this measurement you have mercury barometer, and there are 2 types: 14 and aneroid. And gas is even easier. You just need to know there is 2 manometer, water and mercury, and this formula, which is also similar like this formula, right? But it's in terms of gas. Now, same thing. Read this in 1 minute and intentionally relate this to the drawers. Drawer number 1, the name of the drawer number 1 is Pascal. Number 2 is Archimedes. Number 3 is Bernoulli. Remember the story? Your papa, imagine your papa right in front of you now. And your papa, Archie, in front of this cute baby. Right, and this poor baby, unfortunately, his face is full of your papa Archie. Right, so that helps you to remember Pascal, papa, Archimedes, which is Archie. Then Bernoulli, the baby. Right, so let's do 1 minute to read this. Okay, 10 seconds. Right, now, yes, I think every class I mentioned this, but let me mention this again. I'm not your, for this case, it's physics. Yes, physics teacher, right? I am teaching you my study method, which I call Brain Drawer, and it's having 10 steps. So what I'm doing right now is I am facilitating you, helping you to go through step 1, 2, 3, 4 until 10. And by the end of these 10 steps, based on my experience, all my students will get 7, 8, or 9, or even 10 out of 10. Right? What does it mean? It means that you, in these 2 or 2.5 hours, will be able to understand well this chapter, pressure. Okay? But you need to do quite some readings to be able to achieve that, to help yourself to achieve that. Right? If your goal is this, then excellent. If your goal is to sit here for 2 hours and be able to understand what this chapter is about, well, not just understand roughly, but understand well this chapter is about, then you are in the right class. Okay. Now, we are now in step number 3. Okay. Step number 3. And how do we read this step number 3? This step number 3 is also divided into 6 drawers. Right. So you can see drawer number 1, liquid pressure in liquids, is exactly the same, pressure in liquids. Then now, this step number 3 is having more explanation that is related to what you have read in step number 2, right? So you can imagine that step number 2 for this point number 1 is this this part, but step number 3 in this point number 1 is having more content, right? It's having more content, which is this part. So this is where it will help you to understand what you did not understand just now, right? Okay, so that is how we build our understanding. We build like a Lego. We do the foundation first, like a warming up. Then we start to build something more difficult. That means something more difficult for you to understand on the step 3. Then we could continue on step 4, 5, 6, 7, 8, and 9, and 10, right? So let's do this. How are you going to do this is, remember that you are reading drawer 1, and this drawer 1 is point number 1, which is related to this point, which you read just now. Maybe you understand fully, or you did not understand what exactly it is, it was trying to explain here. Then this is where you'll be able to have more understanding, right? Even if after reading this you do not fully understand, that is fine. We still have step number 4 and number 5 and number 6. Just don't worry. Just need to have you to read it and understand that there are new information here that you do not have compared to what you have read in step 2, right? And that new information is that extra knowledge that you have learned while you're reading this step number 3, right? Let's do 1 minute to start to read this part, 1.1. Okay, right. So let's continue. You're going to do quite a lot of readings for the first 1 hour. So you need to bear with me. If your objective is to be able to achieve this in 2 or 2.5 hours, then just follow the steps and I'll help you to get this, right? So let's do another 1 minute for this actual pressure calculation. And this part is actually this part here that you have read just now. It's just an extension or more elaborations. Let's start now, 1 minute. Ten seconds. Okay. This is the story for each drawer. Papa dived into mercury and pulled by gravity. So Papa is representing the Pascal, or the pressure. Dive into mercury. So this, you have 2 layers, water and mercury. So he's dive into the water, then go into the mercury. So this is to explain 2 things, the depth and also the density, because mercury and water having 2 types of density, and 2 different density, and also depth means he's diving from the water into mercury. That means he's going into deeper territory, right? And pulled by gravity. So you can imagine your papa is diving into the water and into the mercury and is being pulled by gravity. So this is to help you to remember at least one point which is related to this principle, right? Let's go to drawer number 2. Now we are in drawer number 2. We are a bit slow today, so we have to increase our pace a bit. So we will read this for 1 minute. Drawer number 2. Let's start now. Okay. Let's do the environmental effect. 1 minute. Let's start now. Ten seconds. Okay. I hope it's not too fast for you to read this. Right. Next is drawer 3. So let's talk about the short story about drawer 2. Ferdinand Papa breathed oxygen and kentut. Kentut is BM word, I think you know, farting, right? 放屁 in ocean. So Ferdinand represent the 14 aneroid. Sounds like, you know, Ferdinand. So 14 aneroid. Papa is the pressure. Pressure and Pascal. Right? You can use pressure Pascal to represent Papa. Then breathe oxygen. So oxygen is talking about when you are in the high altitudes, you're having less oxygen. Then when you are in the deep undersea, you have this decompression sickness because of nitrogen, right? And kentut, you know, your your fat is having content of substance of nitrogens. So that's how I represent kentut in ocean, right? So Ferdinand Papa breathe oxygen, and then he went to the ocean. He'll go to the ocean and kentut, right? Now let's go to drawer number 3. Drawer number 3 is shorter. Okay, let's do this one. Let's start now. Ten more seconds. All right. So this is pressure remember we have three drawer about pressure: the liquid, the atmospheric, and also gas. So now we are going into the principles, another 3 more principles, which will complete the 6 drawers. Let's do drawer number 4 now. Let's start this drawer number 4. Pascal. Let's start now. Fifteen seconds. Okay, Pascal. Now, drawer number 5, which is another principle. This is the Papa Archie. Papa Archie, right? So let's do 1 minute now. Okay, right. Yes, I forgot to explain the story for Pascal. Pascal is Papa, a strong man with force multiplier. Right. Pascal is related to Papa, strong man to reflect force multiplier. So there is this force multiplier that is in hydraulic system. Right. If you understand this by now, excellent. If you don't, and you only understand part of it, it's fine. This is normal. Right. You just need to know that there is this force multiplier that is being used in the hydraulic system using this Pascal principle. Right. So Papa is a strong man and he is a force multiplier. Then Archimedes, you Archie the water out and splash on your sister face. Right. This is, I think I'll explain this a bit later. Right. Because this requires us to explain the concept. But this is about why the ship is not sinking in the ocean. Right. So draw number 6. Let's start now. Ten more seconds. All right. So drawer number 6 is about airplane. Drawer number 5 is about ship, 船. Drawer number 4 is about brakes, hydraulic brakes for the big lorry or the car, the brakes. Right. If you can imagine, the first one is car, ship, and aeroplane. that maybe will help you to remember what is this principle about, right? So now, first questions. Do you still remember the main story? The main story to help you to remember the drawer's name, which I asked you to, or I requested you to write it down in front of you, in a paper, on the paper, right? If not, then let me recap you a bit. Liquid evaporate to gas. Papa achi at this cute little baby, right? So this is to help you to remember the sixth drawer. Liquid pressure, atmospheric pressure, gas pressure. Then the next one are three principles. Pascal principle, Archimedes principle, Bernoulli principle, right? And each of these drawer, they are having some important keynotes or keywords that you need to know, right? How do you remember this? Either you read from the step 2 and step 3, or maybe after reading that and you translate into a bit of a silly story that will help you to remember, right? So Papa dive into mercury and pulled by gravity. You can also write this if you want as drawer number 1, this is the story. Then drawer number 2, this is the story. Drawer number 3, number 4, and so on and so forth, right? We will have a time slot for you to write it down, the story. But for now, if you have written it down, then it's fine. If not, don't worry. We are going to write it down later, right? So now, go to step 4. Step 4 is the frequent asked questions. Why is this important? This is allowing you to think as in terms of questions, not just reading a book, but think in terms of questions. Why do I need to learn this drawer number 1? Okay, this is drawer number 1. Okay, so when you read this question, first of all, you ask yourself, is this drawer number 1 question, or number 2, or number 3, or number 4, or number 5, or number 6? And to give you a hint, usually it's in sequence. So question 1 is usually drawer number 1, then question 2, drawer number 3, or maybe drawer number 1, depending, but it is in sequence usually, right? So what I need you to do now is you read the questions, and then you ask yourself these questions. What drawer is this? 1, 2, 3, or 4, or 5, or 6, this one. Okay? Then you can read the answer. Okay? Let's do 2 minutes. Let's start now. We'll go slow, so we'll start with 2 minutes. Later we will reduce to 1 minute. Okay, 1 more minute. Thirty seconds. Ten seconds. Right. So This is, if you realize, this is this part, right? This is this part is explaining about the formula of this pressure, depth, density, and gravitations, and explaining much more detail compared to step 2, maybe even step 3, right? So if you see the trend, or you see how I organize it, every steps I'll repeat drawer 1, drawer 2, drawer 3, drawer 4, and it's going to be in a sequence. So now we just started step 4, and is exactly on drawer 1 on this particular first point. Okay, so by now I think you have a better understanding about this P equivalent to H rho G compared to maybe 15 minutes ago when you were on step 2, right? So that's how we build our knowledge step by step. Okay. So let's go to question number 2. Question number 2, whether it's drawer 1 or drawer 2. You tell me later. Okay, let's start. 1 minute. We'll do 1 minute. Let's start now because it's easy. Ten more seconds. All right. So this is question number 2. Question number 2, I think by now you know this is drawer 1. Drawer 1 is liquid, right? Drawer 2 is atmospheric, but this is about liquid pressure. And where is this part here? This part here is related to the applications, the dam especially, right? Now, then the next drawer, the next questions. The next questions should be drawer 2, right? Because we already reached this part here. Let's see whether it's drawer 2. You can read the question and then you can ask yourself, then you can read the answer. Okay, let's start now. Okay, so this is drawer 2 and is particularly explaining this part, the effect of atmospheric pressure, right? So this is how they ask the question, right? How do changes in atmospheric pressure affect humans at very high altitude and extreme sea depth? Remember the story? Papa breathed oxygen and kentut in ocean. So oxygen is the altitude. Kentut in ocean is the nitrogen in the deep ocean. right, in the deep in the sea, right? And that is causing the decompression sickness because of the nitrogen that is inside your body. Now, so I think you understand the trend now, and also the how this is being done, right? So let's continue on question number 4. Which drawer is this? Right, let's start now. 1 minute. Right, this is obviously drawer number 3. If it is too fast, you have to let me know, right? If 1 minute is too fast to read all this, you have to let me know. We just need to increase it to 1.5 minutes. It's fine. Is it? If it is too fast, you raise your hand. Then we can just increase it to 1.5 minutes. If not, then we will continue at this pace. Because everyone's reading pace is different. Okay, but we will follow the one that needs more time. So let's do this for 2 minutes. Let's start now. Question number 2. In total, we have 8 questions. Then we have a break. So 3 more questions to go. This is drawer 4, hydraulic. Thirty seconds. Ten seconds. I hope by now you know what force multiplier with using this equation and using this example, right? The first force is 50 newtons. The area is meter square, and the piston is 100 centimeters square, which is much bigger. And the force of force 2 on the is 1000 newton. So from 50 newton, you created 1000 newton. So this is the Pascal principle, force multiplier. Right. That's why when you drove car before, why this small little push on the brake using your feet can stop the entire car. The entire car is so big. and so heavy. Obviously, you need more force just compared to just this little push from your feet into the brake pedal, and that is the principle of using the principle of Pascal, right? So question number 6. Okay, you tell me, or you ask yourself, which drawer? It's about ship. Ship is about drawer number 5. Remember, drawer number 2 is car. Number 5 is ship. Number 6 is aeroplane. Okay, so let's do it in one minute. I think 1 minute should be fine. Or 1.5 minutes. Let's do 1.5 minutes. Okay, already 30 seconds here. I'll refresh. I'll start again. And that is 1 minute. Ten seconds. All right. Question 7. Two more questions to go. 7 and 8. Then we'll have a 5-minute break for your toilet and your water break. All right. So question number 7. This is looks like drawer number 5, right? Because it's Archimedes and also it's about ocean. Let's see. Let's start 1.5 minutes. Let's start now. Okay, 30 seconds more. Five seconds. All right. Last questions. Last question before we go for the toilet break and water break. Let's do this. This is how does the shape of an aeroplane wing generate the lift needed to fly for flight? This is aeroplane. Aeroplane is drawer number 6, Bernoulli principle. Right? Let's do 1 minute. Okay, before we go for the toilet break, let's do one very quick revision. Very quick one, huh? Very quick one. The main story. Liquid evaporates to gas. Papa achi at baby. Right. So imagine your papa is aching at baby, and also there is this liquid that evaporates into gas. Right. So there are three pressures. Draw number one is liquid. Number two is evaporate, which is atmospheric. Number three is gas. Then there are three principles: Pascal, Archimedes, Bernoulli. Right? Pascal, Archimedes, Bernoulli. All right. Now let's do 5 minutes break, and we'll come back after 5 minutes. Okay, 还有1分钟. Are you guys back? If you are back, just give me a thumbs up. Okay, Singling is back. Dingsam, are you back? Yep. Okay, let us do a quick review. Right, I hope everyone is following, right? At least, okay, what time did we start? 6:12, and now it's 7:07 in less than 1 hour. Less than 1 hour. If your mommy asks you, what do you learn in this 1 hour? To the very least, 最低限制啊，你可以跟他讲 we learn about liquid pressure, we learn about atmospheric pressure, we learn about gas pressure, and also we learn about 3 types of principles: Pascal, Archimedes, and Bernoulli. 最低限制，你至少连到那个 drawer 的名字都可以讲出来，对吗？ Then if you impress your mommy more, then you can tell her about what is liquid pressure and how do you remember what you have learned just now. Maybe from this very silly story, your baba dive into mercury and pulled by gravity, right? Of course, if you tell your mommy, Papa dive into mercury and pulled by gravity, she has no idea what you're talking about. But this story can help you to remember this formula. Then you can start to explain to your mommy that pressure is being the factor that's affecting the pressure, right? For the liquid pressure. And the depth, the deeper you go into the ocean, the more pressure you're going to, and the density. If you are in mercury, or if you're in water, or if you're in any other different liquid with different density, the pressure is also different. Then this is also affected by the gravitational acceleration, right? Then for drawer number 2, you can talk about Papa breathe oxygen and kentut in the ocean. So you can say, okay, this atmospheric pressure that we learned today is when you're in at a high altitude, then the oxygen is lesser. Then you cannot breathe as normally, right? If you're in Mount Gunung Kinabalu and you're in KL, it's totally different. And if you are in deep down inside the ocean, and then you feel decompression sickness, right? For drawer number 3, also you can do the same thing to explain. For drawer number 4, also you can do the same thing to explain. Okay. For the 3 principle, you can even tell your mommy. Pascal principle is about hydraulic brakes. It's about the lorry or the car. Do you know that why when you drive, your feet is just pushing into the brake pedal, and the force that you push into the brake pedal can actually stop the entire car, and the car is something very heavy and it's hard to stop. But your feet, by just pushing into the brake pedal, it can stop because it is using this Pascal principle, right? Archimedes, why big ship like Titanic is not sinking, but why a needle will sink, right? So this is also something that you have learned today that you can explain to your mommy or whoever who you want to explain to. Bernoulli, why plane can fly, right? So in this 1 hour, you actually learn quite a lot of things, right? So if you can read these key words from drawer 1 and drawer until drawer 6 again. Okay, let's do drawer 1 and drawer 3 in 1 minute. Here, let's start now. Drawer 1 until drawer 3. While you're reading, tell me if you feel that you now understood what is written here more than 1 hour ago. Right, let's read first. After 1 minute, then you tell me. All right. Let's do 4 until 6 before I ask you this question. Okay, let's do 1 minute also. Read from 4 until 6. And then feel it, whether you have the same feeling. That now, by reading the same step 2, you are able to understand more. Twenty seconds. Okay, give me a thumbs up if you have the same feeling that you are able to understand more now compared to 1 hour ago. Or if you do not do thumbs up, okay, thumbs up from Jingsam. Okay, good, excellent, excellent. I have the same feeling also because I'm actually learning together with you by going through these steps. Right, I learned this chapter 1 week before you. I never learned this. I learned this, of course, in 30 years ago when I was doing my SPM. But I learned this again one week before you, right? And I'm using these steps. That's why I say I do not claim myself as a physics teacher, but I am teaching you this study method that works for me, and I hope that it's working for you. So now I'm facilitating you, helping you to do this step 1 until step 10 together, right? Okay, so let's continue on the next one, step 5, right? So, okay, before we go to step 5, in 1 hour, 1 hour ago, when you read this, you have very little understanding of what is written over there. 1 hour later, I think you have much more understanding on what is written over here for each of the drawers. There's nothing changed over here. The only thing changed is your understanding has increased as you move from step 2 until step 4, right? So that is the only thing changed. And we are going to continue to build this understanding more by going into step 5, 6, 7, and 8 and 9. Right. So imagine step 2 until step 4 is only 2 steps. And already you can see the difference. What if you reach step 9? Step 4, step 5 until step 9 is more steps. And in that 1 hour, hopefully that we can cover the 4 steps, and your understanding of this chapter is going to be much more than now. Okay, let's see. So let's continue on this way of learning, where I will ask you to read, and I'll give you a timer. Okay, let's divide them into 2 parts, I think. 2 parts. Okay, from here, drawer 1 until this part. 1 minute, let's start now. Until here, 1.2. Okay. I don't know whether you realize this. The readings that you have read just now sounds like there are some repetition. right? Some of the things that you already read it in the step 3 or step 4. If this is also you have the same feeling, then this is good. That means that you already understand that point. Understand the point that is being written over here. And because I intentionally repeating it, like for example, the formula, right? If you discover this trend, then it means that you already understood what is the important points over here. What are the important points over here? If it is new to you now, it's fine also. That means there's a new information that you missed in the previous steps, and now you capture it, right? So both is good. Both are good. So no worry, no worry. Okay, so let's continue on this 1.3 in 1 minute. I'll scroll it up again. If you did not finish 1.2 just now, you can read it. This small part over here.10 more seconds. OK，OK，我再用中文讲多一次，不懂我刚才有讲得清楚吗？用英文刚才，因为我觉得这个很重要。你现在读的这一块是吗？你可能觉得，诶，这个之前的 step 我不是读了个吗？如果你有这个感觉的话，诶，这样这个是对的，这个代表什么呢？你的之前那个 steps 你已经完全明白了，完全明白了这种 liquid pressure 的这种factor that is affecting the pressure，对吧？如果你觉得这个是你第一次看到的话，诶，就代表什么呢？代表你前几个 steps 没有注意到，没有注意到也不用紧，现在这个 step 就让你去注意，然后让你去再多一个机会去明白，是吧？所以我这种读书的方式是有一点重复性的，不过这重复性对于那些学生是 discover，就是他看到，诶，这个好像是重复的，代表什么呢？代表你现在已经在无意中的在复习，your revision，you're doing a revision already. For the student who see this as the first time, then this is the new information that you're learning. Right? That's why I said both are good. No worry. So continue on these steps, then you're gonna understand it more and more. Right? Let's do this 1 minute. Ten seconds. All right. 来，我们走快一点点啊。Now 我们we are in drawer 2. Right. Let me see how long is drawer 2. Okay, quite long. So let's divide into two parts. 2 minutes. Okay, let's start now. 2.2 until 2.2, 2.1 to 2.2. 2.3, we'll do it for the next one. 10 more seconds. Right. Let's continue 2.3. Okay. 2.3 until 2.4. Let's before that, right? For those who wanted to write down the story for each drawer, this is the opportunity to write down. Right, you have drawer 1 and drawer 2 here, you have drawer 3. Maybe drawer 4 later, don't worry. We'll reach there. Now we are in drawer 2. Let's start now.这有点长，我再给多你 half an hour, half minute. Okay, this is done. Remember, drawer 2 is the Ferdinand Papa breathe oxygen and contour in ocean. Right. Remember the story. Then drawer number 3, let me see how long is this. Okay, we'll do it in 1.5 minutes also. Right. Drawer number 3 is you blow U pipe with water and mercury. Right. Just imagine that you're blowing a U pipe. 1.5 minutes. Let's start now. Okay, 1 more minute. 1 more minute. Thirty seconds. Ten seconds. Okay. Let's go to drawer 4, Pascal principle. Pascal principle. Remember, Papa, strong man with force multiplier. So let's do also 1 minute for 4.1, 4.2, 4.3. OK，我们 continue 下一 part。The second part a bit. OK，we'll also do 1 minute. For those who finish reading it, you can read the 4.3 again. Ten more seconds. All right. 4.5. No, sorry. Drawer 5. Drawer 5 is Archimedes. Archimedes, remember the story? You Archie the water out, the water and splash on your sister's face. It's about the ship. Okay, let me explain the story. I think by now you should be able to understand the concept. How the ship is being able to float on the sea, right? Because in order for the ship to sink, you need to have okay, sorry, let me repeat. The ship is carrying the volume, right? Because the ship is being done in a way that there is a big volume that you need to release the water from to have the ship to sink. And every 1 liter of the water is every 1 liter of the water that you need to splash out. Uh, there is a pressure, or there is a force that's needed to push that out. And the ship is having a big volume that is being filled up by air right now, right? The ship that is filling up the cabin, the part that's filling up the empty spaces of the ship, right? And those are the equivalent volume of the water that need to be splashed out from the sea in order for the ship to sink. I hope I am able to explain it well, but for now, let's continue on this draw number 5. Let's see how long is this. Okay, let's do it in 2 minutes. And actually that's the reason why I created this story. Okay, if I did not explain it well, I will explain it again when we reach step 6. Let's read it first for 2 minutes. I'm going to scroll down as we read. Okay, 2 minutes done. Right, I think the key concept here is this one. The volume of the liquid, the volume of the fluid, for this case is the liquid, displaced is equal to the volume of the part of the object that is submerged. The volume of the liquid or the fluid displaced is equal to the volume of the part of the object that is submerged. Okay, let's do this. Draw 6.1, 2, and 3 in 1 minute. Okay, let's continue this one in 1 minute. Ten more seconds. Okay, that is step 5. We finished step 5. Now step 6. Step 6 is about the stories. We have already went through these stories a few times. So this step 6 is particularly addressing the story. So you can see from drawer 1 and drawer 6, each of them is accompanied by a story. And the same story that I told you just now. The first drawer is the pressure in liquids. Papa dive into mercury and pulled by gravity. I hope by now this small story or this little story is able to help you to link it with this formula, right? And how do I remember this story in terms of drawing? You see, this is your papa, and there is 2 layers here. This is what, and let's say this is a swimming pool. You have water on top, you have mercury below, and he's diving into the water, then into the mercury, and this is gravity, and it's being pulled by gravity. So this is the formula to measure the liquid pressure, right? It's not only about the formula, because the question might ask you what are the factors that's affecting the liquid pressure. Then from there, you can talk about the depth, you can talk about the density of the liquid, and also you can talk about the gravitational force, right? Then for number 2, atmospheric, whoever who wants to write it down now, you can also take this opportunity to write it down because it's all over here. It's not scattered in different parts of the keywords. It's all over here, right? So atmospheric pressure is the drawer number 2. You have Ferdinand, Papa, breathe oxygen. So now you see Papa is floating on the sea, in the ocean. and then he's breathing oxygen, and then kentut, this is like kentut, okay, if I, this is like kentut, okay, and this is the ocean, this is the sea, kentut in the ocean. So this is to explain this part here, right, effect of atmospheric pressure. And the Ferdinand itself is talking about 14 and aneroid barometer, right? So 14 is high accuracy, aneroid is fast but inaccurate because it's not using accurate devices. No mercury. 14 is mercury, right? Then draw number 3. Draw number 3 is about Papa strongman with force multi. No, sorry. Draw number 3 is gas pressure. You blow U pipe with water and mercury. So there's this U pipe that you're blowing, half water, half mercury. So this is to explain there is the content of the gas pressure. You have water manometer, you have mercury manometer. Then how do you calculate this? Right, gas is relatively easier. The content is not so complicated, right? So let's go to draw number 4, Pascal principle, Papa strongman with force multiplier. So I think you know this about the brake that I explained, that you can stop the entire car by just pressing on the brake pedal. How? The how is explained by Pascal principle and mainly on the force multiplier, right? 这么你 tug brake 这么小力，你可以停整辆车或者整个 lorry 啊 ，that is the reason, right? Archimedes principle, this is you sneeze, you achi, you sneeze the water out and you splash on your sister face, right? So that is also to explain the Archimedes principle, right? Archimedes principle state that an object which is partially or fully immersed in the fluid will experience the buoyant force equal to the weight of the fluid displaced. Displaced 就是 splash out 的意思哦，是吧？ In the ocean, you cannot splash it out, but if it is in the swimming pool, if the swimming pool is full of water and there is let's say a small boat on the swimming pool, what happened? The water will be displaced out of the swimming pool, right? And that water and that force to force out the water is the force that is forcing the to make sure that the ship is not being sink, right? So that's why I created this story to explain the concept. Then for the Bernoulli principle, you run so fast that you can fly. So that is the Bernoulli principle, right? So Archimedes, this is the drawing. You achi, and then this is the water, and you splash out and you hit your sister's face, or whichever face that you want to imagine that can help you to remember the story. So these are the 6 stories, right? These are the 6 stories. Now, let's go to step number 7, right? Okay, why is this important? Because this is going to help you to do your revision. So ideally, if in front of you the paper, you have this main story, and you have this drawer's name, and you have these stories being written down. Plus, if you are able to even draw it on that paper, then it's excellent, right? Because that is what you're going to use as your reference after these 2 hours. And also during these 2 hours, you're going to use this as a reference, right? So that is your notes. So now let's continue to step 7, right? Step 7. We are almost there. We have step 8 and step 9, which is the easy part, right? Which is watching video and listening to the podcast. Step 7, you have 10 very short questions, quiz questions. How do I want you to do it? Is you read the question, and then you ask which drawer is this, right? That's step number 1. Read the question, ask yourself which drawer. Then step number 2 is before reading the answer, quickly in your mind, you form your own answers using the reference that is in front of you, right? Like the picture, the drawing, or the story, right? Then step number 3 is the answer that you have formed, then you compare with the answer that is written over here, right? So there are 3 steps here. So let's do it in let's do the first one in 1 minute. Then we'll shorten the time for the number 2 and number 3. Okay, let's start now. First step, read the questions. Then identify which drawer is this. Second step, form your own answer. Third step, compare your answer with the answer that is provided. Alright，1分钟有点太长了。OK，不过我们try to do it one round, then the second round you do it by yourself. So for example, why the water outlet of a dam is constructed near its base, and why water shoot at high speed from this outlet. Right, this is obviously chapter 1. Sorry, drawer 1, pressure in liquid. Then if I have to form my own answer, then it will be related to this formula, right? Why is it at the base? 因为 at the base is having the highest pressure, because you see the depth. The higher, the bigger the depth, the bigger the pressure of the liquid, right? H bigger, P also bigger, okay? Then why water shoot out at the high speed of this outlet? It's the same answer, right? Because of the pressure, right? So 我们看一下 the answer. Water pressure increase with depth. So using this formula. Therefore, the pressure at the base of the dam is highest, okay, causing water to shoot out at high speed. Outlets are placed near the base to utilize the high pressure for faster water flow. When the drive turbines often to drive turbines for hydroelectric generations. Okay, right. So my answer just now is similar to their answer. The only point that is being extra over here is this part. It explained further why, which I did not explain. So this is one point or one new information that I have to intentionally pick it up and put it inside my drawer, right? So let's do this. Let's do this 1 minute for question number 2. The same way. Okay, I think it's a bit too long for 1 minute. Okay, let's do this quickly, right? So list the 3 factors that affect pressure in liquid and explain how each factor influence the pressure. This is also drawer number 1, right? Because it's talking about liquid pressure. And the 3 factors obviously is that Papa dive into mercury and pull by gravity. So dive into mercury, dive into 就是它那个depth. Mercury is the density. Then pull by gravity is the gravitational force. Then you explain, right? Explain depth, density, and gravitational force. So the answer is similar to their answer. Then you read this explanation, and that will help you to reinforce your understanding about the depth, density, and also gravitational acceleration, right? So let's do this quickly. We'll do 3 and 4 in 1 minute, right? Let's do it now. This is drawer 2. 10 more seconds. All right, 3 and 4 is done. Let's do 5 and 6. 5 and 6. 5 and 6, I think is drawer 3 and drawer 4. Let's do it 1 minute. Okay, 10 more seconds. All right, 7 and 8. 7 and 8. Let's do it in 1 minute. Ten more seconds. Nine and 10. 1 minute. Okay, 10 seconds. Okay, done. Okay, next one is step 8 is the easiest part and it's the most relaxing part. We are going to watch a video and you have to intentionally tell yourself the video on which part is related to which drawer. And the hint is usually the video is in sequence. It's going to be drawer 1 first, then followed by 2, 3, 4 until 6. Right? So let's watch the video together. Wait, I don't think you can see the video yet. Wait. Come on, hurry up. Okay, I need to reshare. Wait, stop sharing. Share again. Okay, tell me if you.
It's this invisible force that shapes literally
Tell me if you can
everything,
hear this
from the
lady
deepest
who is
oceans
talking just
right
now.
up to the sky.
Give a thumbs up if you can hear the lady talking.
Let's get into it.
Okay, Jing Sam, can you hear?
I mean, have you ever really stopped to think about this?
Jing Sam, okay, good. 这样8分钟，差不多8分钟，okay? Let's start now.
All right, today we're tackling something you can't see, but it's everywhere. It's this invisible force that shapes literally everything, from the deepest oceans right up to the sky. Let's get into it. I mean, have you ever really stopped to think about this? How does a massive steel ship, something that should sink like a rock, just float? Or how does a 500-ton airplane even get off the ground? And get this, how can your foot, with just a little push, stop a 2-ton car? It sounds kind of crazy, right? Like it shouldn't work. But what if I told you there's one single, elegant answer that explains all of it? Yep, the answer to all of these wild questions is pressure. It's this unsung hero, this invisible force behind some of the coolest things in engineering and in nature. And today, we're going to pull back the curtain and see exactly how it works. All right, first things first, we're going to break down what pressure really is. We'll look at it from the bottom of the sea to the very top of the atmosphere. You ever see a big dam? You know how they're always way, way thicker at the bottom than at the top? Well, there's a really good reason for that. It's because of water pressure. All that water is heavy, and the deeper you go, the more weight is pushing down on you. So that base has to be super strong to hold it all back.
Drawer 1.
Okay, so let's get into the nitty-gritty. Liquid pressure is basically the force that a column of liquid pushes down with. And there's this neat little formula for it. P equals H times rho times G. Now don't worry, it's simpler than it looks. H is just the depth, rho is the density of the liquid, and G is gravity. And what's super cool about this is that it means the shape of the container or how much water there is in total, none of that matters. All that counts is how deep you are. Now, here's a wild thought. Right now, you and we're living at the bottom of a giant ocean of air. Seriously, the air above us has weight, and it's pushing down on us all of the time. That's atmospheric pressure. And just like with water, the deeper you are in this air ocean, so the closer you are to sea level, the more pressure there is. That's exactly why climbers on a high mountain say the air feels thin. There's just less of that air ocean pressing down on them. Then, of course, we've got gas pressure. This is what happens when you trap a gas in something, like the air in your car tire. You've got billions and billions of tiny air molecules all whizzing around, bouncing off the inside walls of the tire. All those tiny collisions add up to a big push, and that's the pressure that keeps
这
your
个是 drawer 3 drawer 3. Just now the mountain is drawer 2.
tire firm. So let's do a quick compare and contrast. For liquids, it's all about depth. For the atmosphere, it's altitude. And for a gas in a container, it's about volume and temperature. A diver, a mountain climber, a car tire, 3 totally different situations, but they're all about the same core idea, pressure. Okay, so now we know what pressure is. But the really cool part is what we can do with it. This is where we see how a tiny push can turn into a massive
Drawer
force.
4.
So here's the big idea called Pascal's principle. Imagine you've got some liquid trapped in a sealed system, right? If you push on it in one spot, that pressure doesn't just stay there. It gets transmitted everywhere inside that container, uniformly, instantly. It doesn't lose any strength. It's like a perfect message delivery system for force. And this is how we put that principle to work in a hydraulic system. It's really clever. First, you apply a small force to a small piston. That creates pressure in the flood. Then, because of Pascal's principle, that same pressure travels all the way to a much larger piston. And when that same pressure acts on a bigger area, well, you get a much, much bigger force coming out the other end. That's right, it's a force multiplier. Look at this simple formula. It tells the whole story. The pressure on one side equals the pressure on the other. So if you make the output piston, say, 10 times bigger than the input piston, you get 10 times the force back out. It's not magic, it's just physics, but it sure feels like it. And this isn't some abstract science problem. This is happening every single time you drive your car. When you hit the brakes, your foot is that small force on the small piston. The hydraulic system then multiplies that little push into a massive force powerful enough to stop a heavy car in its tracks. And just like that, we've answered one of our big questions from the beginning. All right, so pressure can multiply
Drawer
force.
5.
Pretty cool. But what about making things float? Let's dive into of what makes things sink or swim. Let me throw a little puzzle your way. Imagine you have a lump of plasticine. You roll it into a ball, drop it in water, and it sinks straight to the bottom. But then you take that exact same lump of plasticine and shape it into a little boat. Now it floats. It's the same weight, the same material. So what's going on? Why does shape matter so much? The answer, my friends, comes from a genius named Archimedes. His principle is this. When you put something in a fluid, the fluid pushes back up on it. We call this the buoyant force. And here's the kicker. The size of that upward push is exactly equal to the weight of the fluid that the object moved out of the way. So that boat shape, by spreading out, pushes aside a lot more water, which means it gets a much stronger upward push. Okay, so let's go back to that giant steel ship. Let's say it weighs 50,000 tons. That's a mind-boggling amount of weight, all of it wanting to pull that ship straight down to the ocean floor. But because of its giant, hollow hull, it also pushes an incredible amount of water out of the way. And if you were to weigh all that displaced water, guess what it would weigh? You got it. Exactly 50,000 tons. And all of that weight creates an upward buoyant force. So you've got 50,000 tons of ship pushing down and 50,000 tons of buoyant force pushing up. It's a perfect balance. The forces cancel each other out, and that's why a massive hunk of steel can just sit there, floating peacefully on the water. Okay, so we've stopped a car,
Row
we've
6.
floated a ship. What's left? Oh, right, conquering the sky. Let's tackle our final mystery. How in the world does a 500-ton airplane fly? You can actually try this one at home. Grab a strip of paper, hold it right under your mouth, and blow a fast stream of air over the top of it. Now, what do you think should happen? Your gut probably says the air will push it down, but try it. The paper actually lifts up, defying gravity. So what's happening here? This little trick is all thanks to Bernoulli's principle. And it's a bit of a weird one, but it's absolutely key. It says that the faster a fluid, and remember, air is a fluid, is moving, the lower its pressure is. So fast-moving fluid means low pressure. That fast air you blew over the paper created a pocket of low pressure right above it. And an airplane wing is basically just a giant, very cleverly designed version of that piece of paper. You see how it's curved on top? That shape forces the air flowing over the top to travel a longer distance, so it has to speed up. Faster air on top means lower pressure on top. The air under the wing is moving slower, so it has higher pressure. And what happens when you have high pressure below and low pressure above? You get an upward push, a really, really powerful one, and we call that lift. So there you have it, floating, flying, braking, all explained by this one invisible force. Once you start looking for it, you'll see it everywhere, from how you drink with a straw to the weather forecast. So my question to you is, now that you know the secret, where else are you going to spot the power of pressure at work today? Think about it. Thanks for tuning in.
All right. Okay. I think it's much clearer right now compared to 2 hours ago. Right. 我们再听多一个 podcast 4分钟罢了。This will help you to reinforce your understanding even further.
Welcome back to the deep dive.
Wait, let me just pull out my notes. Okay, I will highlight the parts, the drawer that they are talking about. Then you just need to focus on listening and look at the highlights.
Today, we're looking at 6 really foundational concepts that govern how fluids work.
We are, from the deepest parts of the ocean all the way up into the sky.
We're talking liquid pressure, atmospheric pressure, gas pressure, Pascal's principle, Archimedes, and of course, Bernoulli's principle.
Our whole mission here is to just quickly connect these ideas for you. And to start, you really have to grasp the basic difference between pressure in a liquid, which, is mostly incompressible, and in a gas, which isn't.
Okay, so let's unpack that. Liquid pressure. Honestly, it's a terrifying concept when you think about it.
It is.
It's all about depth, density, and gravity. So the deeper you go, the pressure just ramps up incredibly fast.
And that ramp up is, well, it's brutal. Just think of a deep sea vehicle, like the limiting factor.
Yeah.
It dives to 11,000 meters. The pressure down there is over 1,000 times what we feel right now at sea level. And this isn't some niche submarine science. It's the exact reason a simple dam has to be built so much thicker at its base. It's all about fighting that crushing force of the water above.
That's the force of water below us. But then there's the force of the air above us. Atmospheric pressure, the weight of the entire sky, basically.
Right, the whole column of air pressing down. But what's so fascinating is that we don't rush,
Why is that?
Our internal body pressure just balances it out perfectly. But if you change your altitude, that balance becomes critical. Go to the top of Mount Kinabalu, for example.
Right.
The atmospheric pressure up there is only about 60% of what it is at sea level, and that drop directly impacts how your body absorbs oxygen.
So you have these massive ambient forces,
Yeah.
oceans, the atmosphere. But what about measuring pressure in, say, a closed system, like a tire?
That brings us to gas pressure. We typically measure that with something like a manometer, and usually it's measured relative to that atmospheric pressure we were just talking about.
And controlling that localized pressure leads right into Pascal's principle, doesn't it?
It does. It's a perfect transition. Pascal's principle says that if you apply pressure to a fluid in a closed container, that pressure is transmitted equally everywhere.
It sounds a bit academic, but this is where humans get to, like cheat and gain superhuman strength.
Exactly. This is hydraulic systems. Your car's brakes, a hydraulic jack in a garage.
Right.
You push with a small force on a small piston, and that pressure travels through the fluid to a much larger piston.
And you get this huge multiplication of force on the other side, an engineered shortcut to a massive mechanical advantage.
Now let's switch gears a bit to Archimedes' principle. This is all about buoyancy, and it answers that classic question: how does a giant steel ship actually float?
I mean, it feels like it should just sink instantly.
It should, but the buoyant force pushing up on it is equal to the weight of the water it displaces.
So the ship just sinks in the water until it's pushed aside a volume of water that weighs exactly the same as the ship itself.
Precisely. And engineers use this all the time. Think about a submarine. It uses ballast tanks to take in or push out water.
So it's actively changing its own weight to control how much water it needs to displace to go up or down.
Exactly. And that brings us to our final one, Bernoulli's principle. This is about flow. High speed means low pressure, and low speed means high pressure.
And this is where it all comes together for aviation. This is how planes fly, right?
This is the absolute basis for it. The shape of a wing, the aerofoil, is specifically designed to make air travel faster over the top surface than the bottom.
So faster air on top means lower pressure on top.
And that pressure difference between the top and the bottom creates an upward force.
Lift. The force that overcomes gravity and keeps a massive airplane in the sky.
That's lift.
I mean, when you put it together, we've just run through 6 principles that explain everything from dams to airplanes.
And they're all interlinked. So here's a final thought. We've mastered engineering for these extreme high-pressure environments, like with those deep-sea vehicles. We can build things to withstand those crushing forces.
Right.
Given that, could that same technology, that understanding of pressure, truly inspire us to build, say, permanent, stable cities under the sea in the future? Is that actually on the table?
That's a truly provocative thought to end on. Keep an eye out for how these forces shape the world around you.
All right, interesting question. How do we build an undersea city? Right now, 现在是8:06，我这边呢。So it's only less than 2 hours. I think you have quite a good understanding about what is the chapter about, right? And you know, by having this main story right in front of you, and the name of the drawer, and also the story inside each drawer. And if you are fast in drawing, then probably you also draw your own version of your drawings. Now we finish step 9. We will go to step 10, right? So step 10 is about questions. So let's pull out the the textbook and upload it into the ChatGPT. Okay, this is the textbook, and the textbook is here. So this is the file that I uploaded just now. So you have 6 drawers: pressure in liquids, atmospheric pressure, gas pressure, Pascal principle, Archimedes principle, Bernoulli principle. By just looking into these 6 drawers, I think you already have a good understanding of what is inside this liquid pressure. What is the content that is inside atmospheric pressure, gas pressure, Pascal, Archimedes, and Bernoulli, right? Especially if right in front of you, you have the story of the 6 drawers, right? So let's take that as a reference. You reference the 6 drawers and also the story that inside each drawer in front of you to see if you're able to answer the MCQ questions, right? So I'll put these keynotes here as a reference, and in front of you, you have also your own reference, which is the story, the name of the drawer, and also the drawings, the story of the drawings, right? Create 10 MCQ to test my understanding of this chapter. Show me 2 questions at once without answer. Okay. So in this chat, right, you can tell me, like, for example, which question? Question 1, drawer 1, answer A, for example. Or you can do, let's say, 1/1/A. Okay. So you can try Dim Sum and Xingling, or maybe Wong. What is your answer? Pressure at a point. Question 1 is D. Question 2 is A. Okay. You also need to tell me which drawer, Dim Sum. So it's like a revision for you to remember the drawer. So question 1, which drawer? Right. So for example, Xingling, question 1, drawer 1, D. Okay. Question 2. Okay. Let's say we have 1, D, 2. 2 is what? 2 is also drawer 1, right? Ticket at the bottom from Dim Sum is A. Is it A? Xingling, what do you think? What do you think, Xingling? Question 2. What's the answer? Do you think it's A? Okay, Xingling is typing, so let's wait. Xingling thinks it's B. I also think it's B. By the way, like I say, I'm also learning together with you. I also think it's B. I think Jing Sum is typing, right? Because the water, yes, the density doesn't increase because there's no different type of waters. It's no mercury or water or oil or some other different waters. It's the pressure, water pressure. Yes, draw 1, yes, exactly. Okay. Okay, I'll ask them to give us the answer later together, okay? So now let's go to question 3 and question 4. Question 3 and question 4. The formula for pressure in liquid is okay. Question 3 is okay. Drawer 1 and B. What about dim sum. Two holes are made at the same level on the side of the booth. When the water flow out, the horizontal distance are the same. This shows that hurry up, hurry up. Number 4. What's the answer? Anyone? C. Okay, I think both are C. Yep, I think so. Let's see. Yes, both. Yep, so 1, 2 also correct. 3, 4 also correct. Let's go to question 5 and question 6. Okay. They already told you the drawer. But then you tell me which number is the drawer. Question 5. Atmospheric pressure. Drawer number what? Five is drawer 2. Yes. A. Is it A? What about 6? B. 5 is B. Okay, let's see. I also think it's A. And B also could be the answer. But I think A is more accurate. Let's see. Yes. Why A is more accurate is because it says inside in a room, and that room could be 在 Mount Kinabalu, Gunung Kinabalu, or KL. Then the atmospheric pressure is different. It doesn't mention exactly which room, but this one mentioned exactly this is the mercury column of this pressure weight, right? If without A, then I would choose B. All right. Okay, let's do 7 and 8. The question 5 is a bit of a tricky question. Pascal and hydraulic system. So question 7, according to Pascal principle, pressure applied to an enclosed liquid is, okay, I have my own answer. Let's see yours. In the hydraulic jack, okay. Drawer 4, B. Yes, I think so. I think it's B also. What about number 8? Remember the force multiplier, the formula. Remember the Papa is a strong man and force multiplier. Here, let's scroll down. Yeah, we are here. Papa with a strong man. Number 8 is anyone? Hurry up, hurry up. 错了，不用紧的。We are not here to test your exam, test you as exam. We are here to learn together. C. Yes, okay. I think also is C. Drawer number 4, correct? Xingling. I think also is C, because remember this formula. The bigger the force, the bigger the surface, the bigger the force. Okay, okay, 又对了两个. Okay, this is the answer. Think some if you did not understand, this is the answer. Okay, last two. 9跟10. Which drawer, which answer? The ship made of steel can float on water mainly because. Nine is B. I also think it's B. What about 10? C. Let me see what is C. What about you, Xingling? Jingsam is not sure whether it's C. Let's wait for Xingling. You think it's C? Or you think it's E? Yes, I also think it's C. Bernoulli laws, right? Right. So Bernoulli principle, according to Bernoulli principle, air move faster above the wing, cause lower pressure above the wing, and higher pressure below, so produce a lift. Right. So I think on average, I think we get about 8, 9, or 10, right? Depending on which answer that you answer just now. After all, whether it's 8 or 9 or 10 or 8 even is a very good result, right? And I hope that you learn something new here. We learn together, and I hope that this learning method is going to work for you. And every week I'm doing the same learning method but different chapter, right? So Jingsam, if you think this helping you in just 2 hours, then you can continue with us in this class. Xingling is definitely going to be here. Xingling, we will extend it to chemistry, right, after Raya holiday. Next week I will not be available because it's Raya. Then I'll keep you informed on the next available date. All right. Jingsam, you're typing something? You want to say something? So I'll wait for you first before I drop. All right. Thank you and welcome. So hope to see you after Raya. Thank you. Bye-bye.